Now, let me first discuss about factorial notation. Before we entering into the concept of permutation, let me first have a short introduction about what is factorial. Let n be a positive integer, then factorial n is denoted by n factorial, or sometimes we denote this by n factorial or factorial n like this, but most probably we use this symbol for n factorial, and is defined as n factorial is equal to, so it is a product of natural numbers up to 1 to n, that is 1, 2, 3 up to product to up to n times. For example, here suppose if 1 factorial means 1 itself, 2 factorial means that is a product from 1 to 2, that is 1 product 2, that is 2, and 3 factorial means product up to 3 starting from 1. So, the value of 3 factorial is 6, then next 4 factorial is the product of numbers from 1 to 4, that is 4, 3, 2, 1, that is equal to 24. So, you must remember all these things, because whenever the value of factorial occurs like 1 factorial, so 1 factorial means that will be easy. If it is 4 factorial or 5 factorial means immediately you know how to, what is the value of these. So, the value of 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24, and 5 factorial is equal to, that is a product from 1 to 5, 5, 4, 3, 2, 1, that is 120, and 6 factorial is equal to product up to 6, that is 6, 5, 4, 3, 2, 1, that is equal to 720, and 7 factorial value, this product up to 7, that is 7, 6, 5, 4, 3, 2, 1, that is a product of numbers from 1 to 7, this value is 5040. So, you must remember all these values in detail, so that whenever the value of that is we execute the value of number of permutation in terms of factorial. So, whenever there is a value of factorial like 6 factorial, 7 factorial means, so you should know these values. So, if it is 6 factorial means immediately you can write that is 720. So, the notation. Now, one more thing I have to mention here, the value of 0 factorial is 1 itself. So, the notation here, n factorial represents the product of first n natural numbers. So, you should remember like this too. What is factorial means? N factorial represents the product of first n natural numbers. So, with this short introduction about factorial, let me now move on to what is the meaning of permutation. So, now permutation meaning. So, what is the meaning of permutation? First, you should know what is permutation. So, permutation is all about arrangements. Permutation is all about arrangements. Arrangements in the sense that order, that is it tells about order. Arrangements in the sense that it tells about order. So, order is very important. So, whenever we speak about permutation, so order is a very important thing. So, permutation is an arrangement of items in a particular order. So, the different ways in which a number of objects can be arranged in a different order is a permutation. For example, suppose I am going to take the two objects A and B, then what I am going to do here is, let me find out the number of ways, that is a different number of arrangement of these two objects. They can be arranged in two different ways, isn't it? One is AB, other one is, you just interchange its position, you get BA. So, AB and BA. So, these arrangements, here we get two arrangements, these arrangements is called permutations. So, these arrangements is called permutations. So, we have here two arrangements, that means we have two permutation. Look at here A, B and B are different. As I told you already, permutation means order is important. So here AB and BA both are different. Here in the first one A occupies the first position, B occupies the second position, whereas in the second one B occupies the first position and A occupies the second position. So order is here important, here both of them are different. Suppose if I am going to, instead of 2, suppose if I am going to take 3 objects, that is let me take A, B and C. Here I have 2 choices. Either I have to take only 2 at a time, that is only 2 objects, either A with B or A with C, that is 2 at a time, or take all at a time. All at a time in the sense that I have to take all the 3 objects at a time. Here I have only 3. So taking all at a time means taking all 3 objects at a time. Then what are the different possible arrangements are there? That is what we are going to find out now. Let me work out this one first. Suppose among the 3 objects I am going to take only 2 at a time. Let me first find out the different possible arrangements are, that is the 2 objects at a time. Then the different possible arrangements are, first you have to fix among ABC, you have to take AB first, then you have to interchange the position, immediately you get BA. Next, here I have to write in ABC, first you have to take AB, then you have to interchange its position, means you get another arrangement. Next, A with C, combine A with C, you get next arrangement, then interchange its position, that is CA. Next, you have to interchange, you have to take B with C, then interchange its position, that is C with B. So these are all the different arrangements. Besides that, we can't give any more arrangements. So we have to give 6 arrangements, 1, 2, 3, 4, 5, 6. So totally we have to give 6 possible arrangements. So totally we have 6 permutations. So among 3 objects, if we have to take only 2 at a time, then the possible, that is the number of permutations or number of arrangements are 6. Instead of that, or suppose if I am going to take all 3 objects at a time, then let me first find out what are the different possible arrangements are there. So for that, so in ABC, here I have to take it here. So first you have to take A as a fixed set, then write down BC. Take it ABC. A is fixed set means just interchange the position of B and C, you get another arrangement, that is A, CB. Next, fix the letter, that is object B, then you have A and C. So BAC. So B is fixed means interchange its position B, CA. Likewise, C is fixed, take C is fixed, they take the remaining 2 objects AB, interchange these 2 positions, you have BA. So besides that, you can't give any more further arrangements. Here itself the total number of permutations we have arrived is 6 itself. So here the total number of arrangements is 6. So as a whole, so permutation means arrangements, where order is very important here. So what is our conclusion based on this is, so the different arrangements of a given number of things by taking some of them or all at a time is a permutation, is about permutation. Here one more question arises. Suppose if the number of objects is 2, 3, 4, something like this, means we have to write down the different possible arrangements and give the answers in terms of numbers. But if the given objects are more than 3, 5, that is 6, more than 10, something like that, means then this process will be very difficult, and find out the number of different possible arrangements. So we are in need of the concept of how to find the number of permutations. Suppose if we are having n objects, out of which if we are going to choose r objects at a time, means then what we are going to do? Definitely it is highly impossible to write down the all different possibilities and give the answers in terms of number. That is a very tedious work, and we can't do this too. So for that we need the concept of how to find the number of permutation. So to find the number of permutations of n objects, we can use the fundamental counting principle or factorial notation. So that's why I have explained the meaning of factorial notation at the beginning. So for this we make use of the concept of factorial notation, because permutations is defined based on the concept of factorial notation. So next, before we move on to how to find the number of permutations for given objects, let me first know what are the different kinds of permutation that we are going to discuss now. The first one, this is what the major part we are going to discuss here, permutation without repetition. The second one is permutation with repetition. After this we are going to discuss this one too. The last one we have to discuss about what is circular permutation. So permutation without repetition means here repetition is not allowed. Based on the word itself you can understand here repetition of any objects is not allowed. Permutation with repetition means here repetition is allowed, that is more than one time. Circular permutation, but based on the name itself you identify, instead of, look at here, these two arrangements is linear permutation, that is here we are going to arrange the objects in a straight line, but here circular permutation means we have to arrange the objects in a circle. So this is what we are going to discuss at the last of this video. Now permutation without repetition means let me explain this in short for you without giving any formulas or anything like this. I am going to take the same example that we have discussed dash before. So suppose if I am going to take the two objects A and B, then the different possible arrangements are, if permutation without repetition means only one, that is every object has to occur only one time, that is AB and BA. So we have only two possibilities. If it is in case of permutation with repetition means, suppose I am going to take the two objects AB, then I am going to find out the number of possible arrangements for this. So for that the different possible arrangements are AB, BA. So in addition to this you have two more arrangements, that is AA and BB. So with repetition means totally we get four possible arrangements. So if it is without repetition means we get only two permutations, that is number of permutation here is only two, here we have four. So listen carefully. So if it is without repetition means in the first position we have only two choice, the first position, whereas in the second position you have one choice. Already we gave first position two choice and the second position one choice. This is what the concept we have followed for permutation without repetition. If it is in case of permutation with repetition, so in the for the two positions, for the first position you have two choices and for the second position too you have two choices, that is when you have to arrange two things you have two chances every time. Likewise if it is 3 means 3 chances every time, like that. Next, circular permutation, this is what we are going to discuss later. I will explain about this after discussing these two. Now let me first know how to find the number of permutation. Here we have to discuss about the permutation without repetition first. For that, based on that we have to first find out how to find the number of permutations, that is the number of all permutations of n things taken on at a time, and repetition is not allowed. Okay, most of the problems in permutation speaks only about repetition not allowed. Some cases if repetition is allowed means that is mentioned in the problem itself. So if it is permutation means firstly we think about permutation without repetition formula alone, because that is NPR is equal to n factorial over n minus r factorial. But this is the formula we have used only, the condition is repetition is not allowed. It's given by NPR is equal to n factorial over n minus r factorial. Now you know how to find the value of n factorial and NPR value. So, for example, if it is 6p2, how to find the value of 6p2 means, that is out of 6 objects, that is there are 6 objects are there, among which you are going to choose only 2 at a time. If so, then the number of possibilities are, that is 6 factorial over 6 minus 2 factorial, that is 6 factorial over 4 factorial, that is 6 factorial divided by 4 factorial means you just write 6, 5 and 4 factorial, because in the denominator you have 4 factorial. So, cancelling both the terms you get 6 5s are, you are 30. So, totally we have 30 possibilities. So, 6p2 value is nothing but 30, which means among 6, if we are going to choose only 2 at a time and repetition is not allowed, means we have 30 possibilities. And like that, suppose if we are going to choose, that is if we are going to find 7p3, that is equal to 7 factorial divided by 7 minus 3 factorial, that is 7 factorial over 7 minus 3 is 4 factorial. So, if you cancel this means you get 5, 6, 7 only, because 4 factorial you get in the numerator and denominator means you get, cancelling these terms you get only 2 10 ways, simplifying this. So, only we have 2 10 possibilities. So, here you have to remember one more thing, number of all permutations of n things taken all at a time. Look at here, among 6 I am going to choose here only 2. Among 7, here I am going to choose only 3 objects at a time. If so, means I am just apply these values of n and r in the formula and simplifying and getting the value. Suppose, let me take the same example here. So, instead of choosing 2 objects at a time, suppose if I am going to choose all at a time means you have to choose 6 out of 6. So, how many number of different possibilities are there, that is different permutations are there means, so what you are going to do as usual, that is you just substitute in the formula, that is 6 factorial over, that is divided by 6 minus 6 factorial. So, simplifying this you get 6 factorial divided by 0 factorial. As I told you already, 0 factorial value is 1. So, 6 factorial. You know the value of 6 factorial is, what is the value of 6 factorial? As I told you already, you should remember the value of 6 factorial as 720. So, the total number of possibilities here are 720. So, if we are going to find out the number of all permutations of n things taken all at a time means no need to substitute and simplifying and getting the answer, that is taking little bit time. So, in order to avoid this, what you are going to do is directly you write. Suppose if the question is calculate 6p6. So, what is your answer? Directly you have to write, that is 6 factorial, write directly as 720. That's good and that's better and good too. So, like this, suppose if it is 7p7. So, what is the value of 7p7? That is 7 factorial. Write down the value. Likewise, suppose if number of all permutations of n things, all of them taken at a time means, so the formula we are going to use is n factorial. So, this one you have to remember. Next, permutations when all the objects are not distinct. Some of the cases that this case arise in most of the problems. Suppose some of the objects are same, then how we are going to find out the number of permutation, that is number of permutations of n objects, of which n1 objects are of one kind and the n2 objects are of another kind. Then if we are taking all at a time, look at the word, when all are taken at a time, okay. If so, we make use of the formula n factorial over n1 factorial product n2 factorial. So, you make use of this formula to calculate the number of permutations under that category. So, before we move on to the problems, let me just have a revise what we are going to discuss so far. Let me have a short look over this, that is n factorial is nothing but the product of first and natural numbers, also the value of 0 factorial is 1. So, NPR, that is the formula for calculating permutation of all objects, that is of n objects taking r at a time is n factorial over n minus r factorial. This only for without repetition, that is permutation without repetition, that is order is a matter here and repetition not allowed. And number of all permutations of n things taken all at a time is given by the formula n factorial. Suppose if one of two are repeated, if there is a repetition of letters or any object, something like this, we make use of this. So, now with this short introduction about permutation, let me now move on to the concept of permutation without repetition. Now, as I told you already, permutation has been divided into three categories, that is permutation without repetition, permutation with repetition and circular permutation. Now, we are going to discuss about permutation without repetition in detail. So, if it is in case of permutation without repetition, it is a vast category. So, in permutation without repetition, you may expect the problems in terms of two categories. Either you may expect the problems in terms of words or you can expect the problems in terms of numbers. First, we are going to discuss about how to calculate these permutations involving words, that is permutation without repetition if it is in terms of words. If based on that you are having so many categories, among that these five are really very important. So, if you understand these things, then the remaining you can, based on these concepts, you will evaluate and give your answers. Okay. Now, if it is in terms of words, means your first category is repeated letters and non-repeated letters. We are going to discuss first, then always together. In always together, we are going to discuss three categories. If it is in terms of consonants, what we are going to do, and in case of vowels or some group of words, how to calculate the number of permutation. Next, never together, that is contrary to this one. Likewise, here itself we have the three categories like this, and odd and even places. If the letters occupies the odd, and that is here we have to discuss if the vowels occupies odd and even or consonants. So, for these two cases we have to discuss what happens if vowels occupies odd place or even place. Likewise, if consonant occupies the odd place or even place, how to calculate the find out the number of permutation. The last one must begin or end or begin and end with a particular letter. Here itself we discuss about repetition of letter is allowed and repetition of letter not allowed. So, if you have completed all these categories, definitely you should have a clear understanding about how to find the number of permutations if it is given in terms of words. With this short intro, let me now move on to general problems under this category first. These are all the very simple problems. First, you have to understand, find the value. This is a direct question, very direct question. So, that is a find the value of 60p3. 60p3 means you know the formula NPR, that is n factorial over n minus r factorial. So, if it is 60p3 means the value of n is 60 and r is 3 itself. So, simplifying this, you get 60 factorial over 60 minus 3 factorial, that is 60 factorial divided by 60 minus 3 is 57 factorial. So, you have to expand the 60 factorial up to 57 itself, that is enough, that is 60, 59, 58 and 57 factorial, 7 factorial over 57 factorial. So, cancelling 57 factorial in both numerator and denominator, you get product of 60, 59, 58. So, simplify, that is multiplying these values, you get, that is 2,05,320. Next, this is a direct question. Whatever may be the value is given means you can evaluate and give your answers either in terms of product or in a simplified form like this, whatever that may be. Next, we move on to another problem. In how many ways can 5 books be arranged on a bookshelf in a library? So, this is all about arrangement. Look at the problem itself. After reading this problem, you understand this problem is about arranged on a bookshelf. So, it is all about arrangements. So, arrangements means order is important. So, order is important means that is under permutation. So, in how many ways 5 books be arranged on a bookshelf in the library? So, that means we have to take all at a time, that is 5p5. You have to calculate the value of 5p5, that is the question. So, if it is 5p5 means, already I told you, the number of all permutations of n things taken all at a time means immediately, no need to substitute in the formula, immediately give the answer as 5 factorial. That is equal to the value of 5 factorial is 120 ways. So, the total number of possible arrangements here are 120 ways. That is number of arrangements of 5, number of permutations of 5 books taken all at a time is 120 ways. Next, how many 3-letter words with or without meaning can be formed out of the letters of the word logarithms? If repetition of letter is not allowed, here it is clearly mentioned that because the the problem in terms of words are given. So, if it is given means definitely they mention that whether repetition is allowed or not allowed. So, here repetition is not allowed. So, if repetition is not allowed means out of first letter we count the number of letters in a logarithm. So, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10 letters, it has 10 letters, out of which you have to choose 3 letter words. So, you calculate 10p3. So, what is the value of 10p3? That is what you are going to calculate. So, the number of 3 letters words formed by using these letters is 10p3, that is equal to 10 factorial over 10 minus 3 factorial. So, that is 10 factorial over 7 factorial. So, cancelling 7 factorial on both numerator and denominator, you get only the products from 10, 9, 8, that is equal to 720 ways. So, totally we have 720 possibilities. With this general problems, now let me enter into the categories. So, in terms of words, if there is non-repeated letters, so in words we have to discuss 2 things. One is repeated and non-repeated letter first. So, first we are going to discuss about non-repeated letters, that is in the look at in the word BIHAR, that is each letter occurs only one time, not more than that. That is the meaning of non-repetition of any letters. So, look at the word. So, let me first read out the question. How many words can be formed by using all letters of the word BIHAR? Here look at the word BIHAR. Here BIHAR contains 5 different letters. It consists of 5 different letters. So, the number of arrangements of 5 letters taking all at a time, that is 5p5 you have to calculate, isn't it? 5p5 means you know already 5 factorial, that is as I told you already. So, if the number of permutations of n things taken all at a time means immediately you write that is 5 factorial. Suppose somebody is doing like this, substituting in the formula means what happens, 5 factorial over 5 minus 5 factorial, that is 5 factorial over 0 factorial, the value of 0 factorial is 1. So, no need to write down all these. So, by practicing definitely you get a clear idea about if it is 5p5 means directly you write. So, this is how you have to save your time in an examination. Okay. So, 5p5 is equal to 5 factorial, value of 5 factorial is 120. So, there are 120 possibilities, that is number of arrangements of 5 letters taken all at a time is 120 ways. Next, if it is in case of non-repeated letters, we know how to calculate number of permutations. In case of repeated letters, then how can we calculate? That is what we are going to discuss now. In how many ways can the letters of the word leader be arranged? Look at the word leader. In the previous problem, BIHAR, BIHAR, so none of the word, that is none of the letters repeat more than once. So, B occurs only one time, I also occur one time, H, A, R, all are occurs only one time. But look at the word leader. Here the leader consists of totally 1, 2, 3, 4, 5, 6. So, the word leader consists of 6 letters, out of which the letter E repeats 2 times, isn't it? Out of which you have 2 times the letter E repeats and the rest are different. That is L occurs only one time, A also, D also and R also, they are all occur only one time. So if it is so, how can we calculate the number of permutation in such cases? Means that is required number of permutations, that is required number of ways is equal to, as usual, if the number of all permutations of 6, that is here we have 6 letters, 6 by taking all at a time, that is 6p6, that is 6 factorial, and divided by, if the letters are non-repeated, your answer is 6 factorial. Here there is a repetition of letters, that is E repeats 2 times, that's why how many times it repeated, you have to write it in the denominator. So the answer is 6 factorial divided by 2 factorial. 6 factorial divided by 2 factorial means you get, that is you get 6, 5, 4, 3 and 2 in the numerator and denominator being cancelled. Simplifying this, you get 360 ways. So whenever there is a repetition of any letters and how many times it repeats, you have to write it in the denominator with factorial notation. This was one of the results we have seen as before, and by make use of this line, how we are going to use of this is by like this we are going to use of this. Next, so in case of words, if it is repeated and non-repeated letters means you know how to calculate the number of permutations. And next one, we move on to always together. Always together means we can't split, while making arrangements we can't split. So these can be further subdivided into 3 categories. First we are going to discuss in terms of vowels, and then we go for consonants, and then we go for some group of words. Under each category in terms of vowels, if it is repeated and non-repeated letters, how can we calculate? Here we have again 2 categories. Likewise in consonants 2 and group of words 2. Again we have 2 more subcategories are there. So now let me first discuss about in always together in case of vowels. Also in terms of non-repeated letters, how can we calculate the number of arrangements? That is, how many words can be formed from the letters of the word signature, so that the vowels always come together. So here it is mentioned that the vowel always come together. Look at the word signature. Signature consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different letters. It consists of 9 different letters. So the condition is the vowels are always come together. Vowels are always come together means you know already what are the vowels: A, E, I, O, U. These are all the vowels in an English alphabets. And the remaining are consonants. So in the vowels, look at the word. Here the vowels are I, A, U and E. So I, A, U, E. By taking these vowels as one letter, that is the vowels can be taken. The given word vowels can be treated as a one letter. So write down the remaining letter as it is, that is S, G, N, T, R. So either you have to take these vowels here or here, that is your choice. I have to take it in the front. So take, that is you have to treat the vowels as only one letter. So this is one letter, this is second letter, third letter, fourth letter, fifth letter, and this is the sixth letter. Now it has only 6 letters. So these 6 letters can be arranged in how many number of ways? 6 letters arranged in 6p6. Taking all at a time means 6p6, that is 6 factorial. 6 factorial means that is 720 ways. Next, the problem is not over up to this. Next, look at the vowels. There are 4 vowels. The 4 vowels can be arranged among themselves in the 4 vowels arranged among themselves in 4p4 ways. That is 4 factorial, isn't it? 4 among 4, that means 4p4, that is 4 factorial means 24 ways. So the required number of ways of words can be arranged is, that is a product of these two, 720 product 24, that is 17,280 ways. Look at here, in the word signature, none of the letters repeated more than once. Each letter occurs only one time. If so, how can we calculate the number of permutation? Suppose if any of the letter is repeated, then how can we calculate the number of arrangement? That is what we are going to discuss next. Before that, in the same problem, instead of signature, if you take optical, 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 next or you may take judge, JUDG. So take these two. For your practice, take these two words under the same condition. Vowels if always come together means how many possible arrangements are there. So test it by yourself. Next, in case of always together, as I told you, if in case of repeated letters, then how can we find out the number of arrangements? That is the next category. So look at the word banking. Here the word banking consists of 1, 2, 3, 4, 5, 6, 7 letters. Now here the condition is vowels always come together. Here the vowels are A and I. Only these two are vowels. Instead of banking, take the word system and find out the number of ways. And this is for your self test. Next, so again we have one more category under vowels. If it is repeated letters in case of combined entry and then the separate letters. So after seeing this example, you will clearly got a clear idea about how can we calculate the number of permutation in case of repeated letters. So in how many different ways can the letters of the word corporation be arranged so that the vowels always come together? Look at the word corporation. It consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So totally it has 11 letters. So in 11 letters, so here we are having the vowels are O, A, I, O. That is O, A, I, O. So these 5 letters are vowels, and treat these vowels as only one entry. That is, we treat the 5 vowels as only one letter, and write down the remaining letters. We get C, R, P, R, T, N. So totally we have 1, 2, 3, 4, 5, 6, 7. So this has 7 letters, isn't it? The word corporation now has 7 letters. Actually, the word corporation has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters, isn't it? Word corporation has 12 letters, but the condition is given that the vowels always come together, means we have to treat these vowels as only one letter. So the 12 letter words become 7 letter word. So this 7 letter word has 2 repeated letters R, isn't it? Here R repeat 2 times. So don't look at the repetition of the letter O now. Okay, while calculating the number of permutation by taking this as a single entry, don't look at is there any repeated words here. This is what we are going to do next. Okay, this is a 1 letter word. So just look at here the remaining words 2 to 7 itself. Is there any letters repeated more than once? Here R repeat 2 times and the rest are different. So if it is though, the number of ways of arrangements, that is number of ways of arranging these letters in, so totally you have 7p7, that is 7 factorial over, since R repeated 2 times I have to take it in the denominator. 7 factorial over 2 factorial means you get only 5, that is 7 factorial over 2 factorial means 7, I have to just write down 7, 6, 5, 4, 3, 2 factorial over 2 factorial. So cancelling these 2 terms and finally get 2520, isn't it? 2520 ways. Now after calculating the number of ways by grouping these vowels as one entry, now let us now come to this one entry. That is, now look at the vowels. This has 5 letters, isn't it? So the 5 vowels can be arranged among themselves in 5p5, that is 5 factorial over, here O repeat 3 times and the rest of the letter only A and I occurs only 1 time. Since O repeat 3 times, so we have to write 3 factorial in the denominator. So simplifying this, you get 5, 4, that is product of 5 with 4, 5 4s are 20, so there are 20 possibilities. So finally the required number of ways a word can be formed as the product of these two, that is number of ways, required number of ways is equal to 2520 product 20, that is 50,400 ways. So now you got a clear idea about if vowels always come together, if it is in case of repeated and non-repeated letters, how can we calculate the number of different possible arrangements, isn't it? So in this problem too, I will give you one example, that is one problem for your self-test. So instead of corporation, take the word preparation, Preparation, take the word preparation and do a self-test. Okay. Now what we are going to in case of vowels, that is what we are going to repeat in case of consonants too. So the question is different. If vowels come together, instead of vowels, if consonants comes together, what we are going to do? The same procedure here itself we are going to follow. So I am just explaining this same concept once again. So instead of vowels, here we have consonants. Okay, the only difference is instead of vowels, here we take consonant. There is no change in the procedure. Okay, now in case of always together, if it is in terms of consonants and if we are having non-repeated letters, then how can we calculate the different number of permutations, that is number of permutations. In how many different ways can the letters of the word education be arranged so that the consonants always come together? So what we do in case of vowels come together means we have to treat all the vowels as only one letter, that is we combine the vowels as one letter and proceed. Here what we are going to do the contrary, we just club the consonants as one letter and proceed as usual. Okay, now look at the word education. So first let me write down the vowels first, then only it will be easy for me to write down the consonants. So I have to write down the consonants here. So I am just strike out the vowels here. So here the vowels are E is a vowel, next U is a vowel, and A, next I and O. Then write down the remaining letters, that is D, C, G, N. So taking the consonants as one entry, by just here what you are going to do is you have to take the consonants as one letter or one entry. So now we have 1, 2, 3, 4, 5, 6. So now we have only 6 letters, but the education word consists of 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. If we apply, if consonants always come together means we have to combine these consonants as one letter, then the 9 letter word becomes 6 letter word, isn't it? So this can be arranged in, these 6 letters can be arranged in, you know already 6p6, that is 6 factorial ways. 6 factorial ways means 720 ways. Look at here, none of the letters repeat more than once, isn't it? So that's why I have to write 6 factorial directly here. And look at the consonants, here the 4 consonants can be arranged among themselves in 4 factorial ways, that is you have only 4 consonants, they can be arranged in, that is 4p4, that is 4 factorial ways, that is 24 ways. So the required number of ways, that is total number of arrangements of all these together is 720 product 24, that is 17,280. So these are all the different possible arrangements. Now for these two I will give you one example for your self test. Take the word judge. So instead of education, if you are going to take the word judge, then what is your required number of arrangements for this problem? Take it as a self test and do it by yourself. Next. So again we have just now discussed about in case of non-repeated letters what happened. Then if we move on to repeated letters in terms of consonant, how can we calculate the different number of permutations? So in how many ways can letters of the word director be arranged so that the consonants always come together? Look at the word director. The word director, I, E, O, these 3 are vowels. So the remaining are consonants, you have to club it as one letter, that is B, R, C, G, R. So take it as one entry. So now you have totally 1, 2, 3, 4 letters. These 4 letters can be arranged among themselves in 4p4, that is 4 factorial ways. And the consonants, look at the consonants, you have 4 consonants and 4 consonants can be arranged among themselves in, again the 4 consonants can be arranged among themselves in, you have 4p4, isn't it? Not only 4 consonants, sorry I made a mistake, 5 consonants, D, R, C, T, R. So the 5 consonants can be arranged among themselves in 5P5, but here, look at here, the letter R repeats more than once, which means we have to write it in the denominator. So that is 5 factorial over 2 factorial, that is product of, after cancelling 2 in both numerator and denominator, you get product of 5, 4, 3, that is 60 ways. So the required number of ways is nothing but the product of these two. So the required number of ways is equal to product of these two is nothing but 4 factorial, that is 24 product 60, 1440 ways. So totally you have 1440 ways. So whenever there is a repetition of letter, you have to write it in the denominator. Okay. So in how many different ways can the letters of the word corporation be arranged so that the consonants always come together? Here in both in terms of corporation, look at the word corporation. Here it has the vowels. First you have to write down the vowels. O, O, A, I, O is a vowel. The remaining are consonants. What are the consonants? C, R, P, R, T, N is a consonant. Taking these as one letter, you have 1, 2, 3, 4, 5, 6. So totally you have 6 different letters. If you are having 6 different letters, the number of ways of possible arrangements are 6 factorial. But look at here, the letter O repeats 3 times and the rest are different. So you have to write it in the denominator. And look at the consonants. Here you have 1, 2, 3, 4, 5, 6. 6 consonants, and the 6 consonants can be arranged among themselves in 6 factorial ways. Also here, look at the word letters C, R, P, R, T, N. The letter R repeats 2 times. So you have the 2 factorial in the denominator. So the required number of ways is nothing but, that is a possible number of ways of arrangement is product of these two, that is 6 factorial divided by 3 factorial, product of 6 factorial divided by 3 factorial. Simplifying this, you get the answer, or you may get the answer like this too. Next. So we have completed 2 cases. So far we have completed 2 cases in case of always together. So what happens in case of vowels and consonants? In these 2 categories, in repeated, both repeated and non-repeated letters, how can we calculate the different possible permutations? Okay. Now, if it is in terms of letters, so no need, so in all cases not necessary in terms of vowels and consonants. Sometimes if it is in terms of some group of words or letters, so how can we calculate the different possible arrangements? That is what we are going to discuss now. Under this category too, we are having 2 cases. If it is in case of non-repeated letters and repeated letters. First we have to take non-repeated letter first. Among the arrangements that can be made by using all the letters of the word crystal, in how many arrangements, that is AC, come together? Look at the word crystal. If you take AC, either you have to take it at the beginning or at the end, that is your choice. Here I have to take it at the beginning. If AC come together means you have to take these two as only one entry, then or leaving A and C, you have R, Y, S, T, L. So total you have 1, 2, 3, 4, 5, 6. 6 letters. So the total number of possible arrangements is for 6, among 6 means 6 factorial. And look at the clubbing, that is here we have to take AC as one letter. So the 2 letters arranged among themselves in 2 factorial ways, that is AC and CA. So the required number of arrangements is 6 factorial product 2 factorial, isn't it? That is 1440 ways. So next we move on to repeated letters in case of group of words. Among the arrangements that can be made by using all the letters of the word nation, in how many arrangements N come together? Okay, here it is given that N come together means here there are 2 N's are there. Sometimes if it means more than 2, okay, this is based on the given word itself. Here we have to take n as one letter. Okay, taking n as one letter and write down the remaining letters, that is A, T, I, O. So totally we have 1, 2, 3, 4 and 5 letters. These 5 letters can be arranged among themselves in factorial ways, isn't it? And the rest of the 2 letters n can be arranged in only one way. No need to write the answer. Okay, your final answer is 5 factorial. Problem over. Suppose if you want to write it as on procedure, means the 2 letters arranged among themselves in 2 factorial, isn't it? 2 factorial ways, but here there is repeated letters, isn't it? That is repeated letter, that is n repeat 2 times. So you have 2 factorial over 2 factorial, that becomes 1 factorial. That's why I told you no need to write it. Okay, because here 2 of them are same. Suppose instead of n, suppose here you are having A or B or anything like that, means definitely you have to give your answers, that is 2 factorial alone. So you have to find, that is multiply that 2 factorial along with this 5 factorial. Okay, but here these 2 letters are same letter, so no need to write down the possible arrangement, because that value gives you 1 as the result. That is to be understood if you practice a lot of problems under permutation. Is definitely these concept is always in your mind and you can directly give your answer as 120 base. 5 factorial or 120 base. Now we have completed always together. So we have come across 2 things. If repeated letters and non-repeated letters, how can we calculate the number of permutations? And also in case of always together, we have discussed 3 categories, that is in case of vowels, consonants and group of words. The next thing is never together. That's contrary to always together, isn't it? If it is in case of never together, we don't go for any new procedure. We already know how to calculate the total arrangement, and also how can we calculate the number of arrangements if the vowels come together and consonants come together, or any group of words comes together. That's also we have discussed. So by making use of these, we calculate this. That is under never together. For that, excuse me, that is a total arrangement. The total arrangement is given by never together plus always together. This is what you know, isn't it? If it is total arrangement, means that total number of arrangement consists of all, that is never together and always together, everything it has. But here we need never together, either it may be some group of words or some vowels or consonants, whatever that may be. Okay, so in our problem, all the letters A, B, C, D, E, F, G up to G we have to take or arrange. Find the number of arrangement in which A, B, C never together. If it is never together, means A, B, C never together. If it is always together, means A, B, C always together. So if so, how can we calculate? Means you make use of this formula. If it is never together, means that is equal to, so you need this value, isn't it? Never together is equal to total number of arrangements minus always together. Am I right? This is the concept underlying this. Always together. So the total number of ways of arranging, here we have 1, 2, 3, 4, 5, 6, 7. None of the letters is repeated, but totally we have 7 letters. So the number of ways of total number of arrangements is total arrangement is equal to, that is 7p7, or directly you can write 7 factorial. If it is 7 factorial, means as I told you already, that is the value gives you 5040 ways. So we calculate total number of arrangement. Next, what we need? Always together. If A, B, C is always together, then how can we calculate the number of permutations? Now, if A, B, C together, then what we are going to do here is, we have to take A, B, C as one letter and write down the remaining letter D, E, F, G. Now we have 1, 2, 3, 4, 5. So now we have 5 letters. These 5 letters can be arranged among themselves in 5 factorial ways, isn't it? And look at the word, that is the letters A, B, C. Here the A, B, C are arranged among themselves in 3 factorial ways. Here none of the letters repeats more than one, so we directly write 5 factorial and 3 factorial ways. So the total number of possible arrangements, 5 out of 5 is 5 factorial. So look at the letters A, B, C. Here 3 letters are there. 3 letters can be arranged among themselves in 3 factorial. So the total number of possible arrangement is 5 factorial product 3 factorial. So that is equal to 720, isn't it? So now we calculate the number of arrangement in which A, B, C never together is. So never together A, B, C is equal to total number of arrangement is that is 5040 minus always together is 720. So subtracting this you get 4320 ways. Okay. So this is your final answer. So if it is never together means, already we know how to calculate the total number of arrangements. If it is always together means, how can we calculate the number of permutation? So we make use of those two concepts. We calculate never together. If it is in terms of letters or words, consonants, vowels, whatever that may be, we use the same procedure. For that you have to remember this formula, never together is equal to total number of arrangement minus always together. Or otherwise, this is a general concept you have to understand. If it is total arrangement means that consists of both never together and always together. Okay. Then by make use of these two you can calculate. If you need never together, so take this term to other side and calculate. Okay. So with this, next we move on to odd and even places. So what happens if for example the vowels occupy only odd position or consonants occupy only odd positions or even positions? Okay, how many different possible ways of arrangement are there? If it is in terms of like this, then how can we calculate? That is what we are going to discuss now, odd and even places. Here I have to take 3 examples. Okay, in how many different ways can the letters of the word detail, machine, founding be arranged in such a way that the vowels occupy only the odd positions? So in this category I have to give you both of the things simultaneously. If it is in case of repeated letters and non-repeated letters, repeated and non-repeated letters, how we are going to calculate? Okay, I will club these two things in single example like this. So let me first take detail. In the word detail, none of the letters repeat more than once. Next I am going to take machine, M-A-C-H-I-N-E, machine as a next. Here machine 2, look at the letters, is there any repetition of letters? Look at it. Next, none of them repeat more than once. Next, founding, F-O-U-N-D-I-N-G. So here there is a repetition of letter, isn't it? So now let me first discuss about detail. So the condition is the vowels occupy only the odd positions. Okay. So look at the letter, that is a word detail. You have 1, 2, 3, 4, 5, 6. You have 6 letters in the given word, isn't it? The word detail consists of 6 letters. Okay, the word detail consists of 6 letters, of which what you are going to do here is vowels occupy only odd position. Let's first find out what are the vowels here. What are the vowels here? E, A, I. Okay, this is I and detail. So these three are vowels and the remaining are consonants. So the word detail consists of 3 vowels and 3 consonants. Am I right? So it has 3 vowels and 3 consonants. Now let me make them portions as under 1, since it has 6 letter word, 1, 2, 3, 4, 5, 6. So there are 6 portions. So among these 6 portions, the first portions again 3rd, 4th, 5th and 6th portion. So in these 6 portions, vowels occupy only odd portion, that is first, either first or third or 6th. So here we have 3 portions and only we have 3 vowels, isn't it? So we have 3 odd portions, 1, 3, 5 are the 1, 3, 6 are the 3 odd portions. For that we have 3 vowels. So the 3 vowels can be placed at any of these 3 odd places, either 1, 3 and 6. So the number of arranging, that is the number of ways of arranging the vowels is that is 3 vowels. Among 3 vowels we have only 3 portions, so that is in 3p3, that is 3 factorial, that is 6 ways, isn't it? Next is consonants. Let me move on to consonant. We have 3 consonants. So already we leave the odd portions to vowels, means remaining portions we have 2, 4, 6th portion. So 5th is an odd portion, sorry I made a mistake. 5th is an odd portion, 1, 3, 5 is an odd portion. If we leave 3 odd portion for 3 vowels, and we have 3 even portions, that is 2, 4 and 6th portion for consonants. If we have 3 portions, the 3 consonants can be arranged at the remaining 3 portions, isn't it? So the number of ways of arranging the 3 consonants is, you have 3 portions, among these 3 you have to arrange the 3 consonants, that is 3 factorial, that is 6. So the total number of arrangement is 6 product 6, that is 36 ways. This gives you the total number of arrangements. Okay, the first one is for vowel and second one for consonant, number of arrangement. Am I right? Now here none of the letters repeated more than once. So and also the portion also, if we have 3 vowels means equally we have 3 odd portion, that 1, 3, 5, and 3 consonants we have equally 3 even portions, that is 2, 4, 6. If so, definitely our total number of ways of arrangements is equal to 36 ways. Next we move on to the next example, machine. Look at the word machine. It consists of how many vowels? 1, A, I, E. So it has 3 vowels, that is A, I, E, and it has 4 consonants. So remaining are consonants. So 1, 2, 3, 4, 5, 6, 7. So machine is a 7 letter word. 1, 2, 3, 4, 5, 6, 7. So machine is a 7 letter word. So it consists of 3 vowels and 4 consonants. Okay. But here we have first, third, fifth, 7. 4 odd places, but we are having only 3 vowels. Am I right? So in 4 odd places, 3 vowels. We have only 3 vowels, isn't it? 3 vowels can be arranged in in 4 out of 4 you have to arrange only 3, that is 4p3. That is, you simplifying this you get 24. Am I right? Next, come to in case of consonants, we have 4 consonants. For 4 consonants we have only 3 portions, whereas that is only 3 even portion and 1 odd portion, because we have only 3 vowels. So one of the odd portion left in odd places. So we make use of any of the odd places. So the 4 consonants can be arranged in the remaining 4 positions in 4 factorial ways. That is 4 factorial is 24 ways. So the total number of arrangement is product of these two. So the total is equal to 24 product 24. That is equal to 576 ways. Okay. So next we move on to the next case, founding. Here the word founding has 3 vowels and 5 consonants, isn't it? O, U, I are the 3 vowels and the remaining are consonants. Since it is a 8-letter word, am I right? Since it is a 8-letter 1, 2, 3, 4, 5, 6, 7, 8. So here we have 3 vowels. So if we have 3 vowels, if you just mark the odd position, we have 1, 3, 5, 7. We have 4 places, but we have only 3 vowels. So 3 vowels, that is in 4 odd places, the 3 vowels can be arranged in 4p3 ways. Just now we have seen. So in 4 places, 3 vowels can be arranged in 4p3 ways, that is in 24 ways, isn't it? Next, remaining we have 5 consonants. How many consonants are there? 5 consonants. What are the 5 consonants? And here I am going to write. The 5 consonants are F, N, B, N, G. Here O, U, I are vowels. The 5 consonants are F, N, D and G. Look at the 5 consonants. Here N repeat 2 times. So the 5 consonants can be arranged in 5 factorial divided by 2 factorial ways. So the total number of ways is nothing but the product of these two, that is 5 factorial divided by 2 factorial, product of that is 24, which gives you 1440 ways after simplifying this. Okay. So if it is repetition of letter means no problem, as usual you have to write it in the denominator, that's all. Okay. So with this you got a clear idea about how to calculate the number of different arrangement in case of odd and even places. Next, the last thing we have to discuss about, must begin or end or begin and end with a particular letter, then how can we calculate the different number of permutations or arrangements. That is what we are going to discuss now. So as a simple example, first I am going to take in the arrangements of A, B, C, D, E, taken all at a time, how many of them begin with A. So here you have to take, since we are having 1, 2, 3, 4, 5 letters, that is 1, 2, 3, 4, 5 letters, the condition given here is the A will be in the first position, isn't it? A will be in the first position and the remaining letters, that is at the second position, second, third, fourth, fifth position. So A will be in the first position, then second, third, fourth, fifth position can be arranged. That is, we are having remaining 4 letters, that is 4 position. The remaining 4 letters, arranged in 4p4 ways. That is 4p4 means 4 factorial, that is equal to 24 ways. So the required number of ways of arrangements is equal to 1 product 24. No need to write it 1, but if you understand the concept, definitely I have to here mention that 1 product 24, that is equal to 24 ways. Why I am going to mention here 1 as only one possibility for the first position. That is only one possibility for the first position, that is only A alone, because it is given that first position is only occupied by the letter A itself. So the remaining 4 positions alone we have the different arrangements, that is different possibilities. What are the different possibilities? That is what we are going to calculate. So one thing I have to mention here, just remember that carefully. Listen, here there are 4 positions, okay. If it is 4 letters, okay, 4 letter, I have to take the same example so that you can understand clearly. Here, if it is 4 letter and you have 4 positions, am I right? If it is 4 letters and 4 positions, means the different number of possible arrangements is 4 factorial. There are 4 factorial ways are there. 4 factorial means 24 ways of arrangement. You can give by shuffle the letters, you can arrange them in 24 ways. But if it is 4 letters and there is only one position, if so, you have only 4 ways. Okay, either you have to place the first letter, second letter, third letter or fourth letter. That is only different. I think you got a clear idea about this. If it is 4 letter, 4 position means the total number of possible arrangement is 4 factorial. If it is 4 letters, only one position means either you can place the first letter A or B or C or D. Either one of them you can do at a time. So you have only 4 different ways alone. Okay, this is the important thing you have to remember, right? So in this problem, let me take A in the first position. So if you are going to take A in the first position, the question is the arrangement we are going to take all at a time. All at a time means here we have, it's a 5 letter, it has 5 letters. The remaining 4 positions can be arranged themselves in 4 factorial ways. So in the first position we have only one option, that's why I have to take one product. Remaining arrangements are 24, that is 24 ways. I think you understand the concept now. Okay, now let me now move on to a problem under this category, including all, that is beginning, ending, begin and end, and any one of them occupy the beginning or end place. Now, how many permutations can be made out of the letter of the word computer? How many of these begin with C, end with R, begin with C and end with R, C and R occupy the end places? These are all the different categories we are going to calculate for the same problem. So the first question is permutation which begin with C. Let us calculate the permutation which begin with C. So the word computer consists of 8 different letters, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. So totally we have 8 different letters, of which if C occupies the first place means, so 1, 2, 3, 4, 5, 6, 7, 8. The first position can be filled. So in the first position you have only one choice, so C. For the first position you have only one choice, that is C. The remaining 7 letters, so leaving the first remaining you have 7. So the remaining 7 letters can be arranged in 7 factorial ways. Am I right? So the total number of permutations which begin with C are 1 product 7 factorial, that is 7 factorial values 5040 ways. Next, if it is end with R, the same procedure. Since it is a 8 letter word, 1, 2, 3, 4, 5, 6, 7, 8. The 8th position you have R. 1, 2, 3, 4, 5, 6, 7. So you have only one choice in that is the last position can be filled in only one way. So the remaining 7 letters can be arranged in 7 factorial ways. So as I told you already, 7 factorial is 5040 ways. So the total number of permutations ending with R are 5040 ways. So next one is begin with C and end with R. If it begin with C, that is the first letter is C. 1, 2, 3, 4, 5, 6, 7, 8. In the 8 letters, the first position is occupied by C and the last position is occupied by R. If the first position can be filled in only one way, that is you can take only C alone, and also the last position, okay, sorry, and the last position can also be filled in only one way, that is R. So one product, that is this is what the value we have to calculate. So this is equal to one product. Remaining how many letters left? 1, 2, 3, 4, 5, 6. So the 6 letters can be calculated, that is can be arranged among themselves as one product 6 factorial product 1. No need to write it 1, but to give you a clear concept about this, So you know the first and last position having only one choice. So the remaining 6 letters can be arranged among themselves in 6 factorial ways. So the total number of permutations which begin with C and end with R is 6 factorial ways, that is equal to 720 ways. That is the value of 6 factorial is 720. Next, permutation with C and R occupies the n places, then how can we calculate? So if C and R occupies the last place, that is 1, 2, 3, 4, 5, 6, 7, 8. So the last two position, either you have to take C here and last you have to take R, or interchangingly you have to take R or C, whatever that may be. So here, look at here, the remaining 6 letters, if C and R occupies the n positions, definitely here we have 2 possibilities, isn't it? 2 possibilities, either C or RC, and the remaining 6 letters can be arranged in 6 factorial ways. So the total number of permutations in which C and R occupies the n places is 1400, and that is multiplying these two values you get 1440 ways. So up to this you got a clear idea about how can we calculate if any of the letters, if any of the problem is given and must begin or end or begin and end with a particular letter. So in the previous problem, none of the letters is repeated more than once. If it is repeated more than once, then how can we calculate the different possible arrangement? That is what we are going to discuss under the same category right now. Now, in how many different ways the letter of the word Uganda can be arranged such that G always comes at first place and N always comes at the last place. So in the word Uganda, so Uganda, here G occupies the first position and N occupies the last position. Uganda is a 1, 2, 3, 4, 5, 6 letter word. So first and sixth position is G and N. It is given. Remaining 2, 3, 4 and fifth position, we have to calculate the different possible arrangements. Here the total number of letters is Uganda has 6 letters. Okay, when G occupies the first place and N occupies the last place, of which here A repeats. The word Uganda, A repeats more than once, that is we have 2 times. So we have in the central position we have 4 letters. So the 4 letters which can be arranged in 4 factorial ways, of which leaving G and N you have U, A, D, A. These 4 letters can be arranged in 4 factorial ways. Here the letter A repeats more than once, that is 2 times. You have the total number of possible arrangements are 4 factorial divided by 2 factorial ways. So the required number of ways is equal to 1 product 1. Since the first and last position having only one choices, in the center portion the 4 letters can be arranged among themselves as 4 factorial ways, of which the letter A repeats 2 times, so you have to take 2 in the denominator. So the total number of possible arrangements here are, simplifying this you get 12 possible arrangements. So up to this we have discussed all the categories, that is under permutation without repetition if it is in terms of words. So if it is words and number, as I told you already, permutation without repetition means you can expect problems in 2 categories, either in terms of words or in terms of numbers. If it is in terms of words, we have discussed the different cases. Okay. If it is in terms of numbers, here you have only 2 categories including 0, that is 0 and non-zero. Here you have 2 categories. So I will explain how to calculate the different permutations based including 0 and non-zero numbers. So now let me move on to under permutation without repetition. Let me now move on to numbers. Okay, words we have discussed Just that is, we have completed the discussion about words. Next we move on to numbers under permutation without repetition. Okay. So under this we are going to discuss these two categories, that is including zero and non-zero numbers. Okay. Now in case of numbers in permutation without repetition, if it includes non-zero numbers, non-zero numbers means except 0. Okay. In how many ways at 2 digit, at 3 digit and 4 digit number can be formed using 6, 7, 8, 9. The letters 6, 7, 8, 9, that is the digits. Okay. So here you have 4 digits. So first one is, how can we form 2 digit number means in 4, out of 4 you have to form 2 means 4p2. What is the value of 4p2? That is 4 factorial over 4 minus 2 factorial. This you know already, that's why no need to explain. So anyway, since it's the first problem, I did elaborately. So 4p2 is nothing but 12 ways. So it is as we do in case of words too, the same process here. Okay, if it is in terms of 4p3, if it is in terms of 4p3 means 4 factorial over 4 minus 3 factorial. By make use of the formula, you know already NPR is equal to n factorial over n minus r factorial. So you have to take n as 4 and 3, you simplifying this you get 4 factorial, that is 24 ways. And next one 4p4 by taking 4 digit, that is 4p4 is 4 factorial over 4 minus 4. You know 4 minus 4 is 0, that is 1. 0 factorial value is 1. So here itself you get 4 factorial ways. So these are all some general problems you can directly answer without having much difficulties, isn't it? So let me move on to the next one, how many ways. Here look at here, none of the digits repeats more than once, 6, 7, 8, 9. Okay, none of them repeats more than once. So as usual we do in case of words. That is the problem we have discussed under words. In how many ways a 2 digit and 5 digit number can be formed using 1, 6, 7, 8, 9, 6. Here the digit 6 repeats 2 times. So the first question is, how many ways can form a 2 digit number, that is out of 5. So okay, out of 5 you have to form 2 digit number, that is 5p2 you have to calculate. 5p2 you have to calculate, that is in the denominator you have 6 repeated 2 times, isn't it? So you have to take it in the denominator. So 5p2 divided by 2 factorial, that is equal to, so simplifying this you get 10. Next, in case of 5 digit, so 5 digit number means you have 5 and by taking all at a time 5p5, since the digit 6 repeated 2 times you have to take it in the denominator. So 5p5 divided by 2 factorial. So simplifying this you get 5p5 is 5 factorial divided by 2, you get 60, that is 5 factorial is 120, if you divide by 2 you get 60. Okay. Now let me move on to the next, that is the last one, how many 7 digit numbers can be formed using these digits 1, 2, 3, 4, 5, 6, 7. So totally here we have 7 digits are there. So there are 7 digits here, of which here 7 repeats 3 times and 6 repeats 2 times. So the total number of permutation is, so you have to form 7 digit number. So 7 by taking, that is all at a time means 7 factorial, isn't it? So 7 factorial divided by, here 7 repeats 3 times, so you take it in the denominator, and 6 repeat 2 times, so you got take it as a product and write it in the denominator. This gives you the answer as 420 ways. After simplifying you get 420 ways. So in terms of numbers, that is if it is in terms of non-zero numbers with the repetition and without repetition of digits, then how can we calculate the different permutations, the different number of arrangements? That is what we have discussed now. Now let me move on to the next category, that is including 0. So the number including 0 means, look at this problem and I explain you how can we calculate the different possible arrangements and give you the answer for this question. Okay. In how many ways a 4-digit number, look at the question first carefully, in how many ways a 4-digit number can be formed using 0, 6, 7 and 8. So amongst 0, 6, 7, 8, how many 4 digit numbers can be formed? This is what your question. So as per the concept, what you are going to do as usual, if it is in terms of letters, so there are 4 letters A, B, C, D means how many 4 letters words can be arranged, okay, among themselves in you have without repetition 4P4, you have to give your answer 4 factorial and finish the question, okay. But here including 0, so you can't proceed like that, okay. That why I am going to explain this is, look at this. Now first, if you are going to, since it is a, now I am going to form a 4 digit number, so I have 4 positions, okay. So in the first position, if I am going to take 6, so the remaining we have, if we am going to fix the first position as 6, remaining I am going to take either 0, 7, 8. So for the 3 digits here 3 positions are there. For the 3 digits here we have 3 positions. So the 3 positions can be filled by 3 letters in 3 factorial ways or in 6 ways. Am I right? Next you have to fix the first letter as 7. If I am going to fix the first letter as 7, the remaining 3 positions can be filled by the 3 digit numbers in the same 6 ways. That is 3 factorial, that is in 6 ways. If it is first position is fixed means either you can take, then you have to take 3 digits as either 0, 6, 8 and you have to shuffle and you have to give your arrangements in 6 possible ways of arrangements. Next, if you have to fix the first position as 8, then the remaining 3 digits, that is 0, 6, 7 has to be arranged in the 3 positions in the same 3 factorial, that is 6 ways. Let's come to the last one, 0. If I am going to take 0 at the first position, then what happened? The remaining 3 positions, shall we proceed as we do in case of the previous like 6, 7, 8? No, you can't do like this. If you take 0 at the first position, definitely the 4 letter, that is the 4 digit number becomes 3 digit number. Am I right? If you take 0 at the beginning means this becomes a 3 digit number. But the question is, you have to form a 4 digit number using these digits. So you can't take 0 at the beginning, okay. So you can't take 0 at the beginning because of the reason that if you take 0 at the beginning, the 4 digit number becomes a 3 digit number. So you omit this choice. So the total number of possible ways of arrangements is that adding all these values, that is 6 plus 6 plus 6, adding these 6 values, you get 18 ways. So the total number of ways of possible arrangements of 18 ways. Then next we move on to permutation with repetition. As I told you already, but as in case of permutation means we are going to discuss 3 different categories, that is permutation without repetition, permutation with repetition and circular permutation. If it is permutation without repetition means we have 2 cases we have discussed, that is if it is given in terms of words and if it is given in terms of numbers, then how can we calculate the different possible arrangements? That's what we have discussed so far. Next, let's we move on to permutation with repetition. If it is permutation with repetition means here itself we have 2 categories, either in terms of words as we do in case of previous, that is permutation without repetition, as we do in case of previous, that is in case of words and numbers. If it is words, either we have 2 categories, that is repeated and non-repeated, and in terms of numbers we have including 0 and non-zero numbers. So the same we are going to discuss under permutation with repetition, okay. That is, as I told you already, permutation without repetition means by taking the 2 objects A, B, the different permutation without repetition means A, B and B alone we have to give. If it is in case of with repetition means A, B, B, A, besides that you can give A, A and B, B too. That is, for each possible arrangement you have n choices, that is 2 choices every time, okay. By arranging n things you have n choices every time, okay. This is the meaning of permutation with repetition. That is, repetition of letter is allowed here. Okay. Now, permutation with repetition. So, to calculate the number of permutation under this case, we make use of the formula n par r. In case of without repetition, we make use of the formula npr is equal to n factorial divided by n minus r factorial. But in case of with repetition, that is the number of permutation of n different objects taken or at a time where repetition is allowed, as given by the formula n par r. Now, let me now move on to directly a problem. In how many ways can we select two of these letters A, B, C, D when repetition is allowed? So, repetition is allowed means order is a matter and repetition allowed. Is it correct? Am I right? Okay. Now, you have to select two of the letter among 4. If you select two of the letter among 4 means here n is equal to 4 and r is equal to 2. Is it correct? N is 4, this is your value of n, and r is equal to 2. So, 4 par 2. If it is in case of repetition allowed means you make use of the formula n par r, that is equal to 4 square. 4 square is 16 possible selections, that is or arrangement, 16 possible arrangements are there. Or otherwise I have to say this as, I have to explain this for in clearly as you have to select only 2 letters. So, in the 2 letters, for the first letter and second letter, we have to choose only 2 letters. For the first letter, you have 4 choices. Am I right? Since we have A, B, C, D, 4 letters. So, for the first letter, you have 4 choices. So, total number of choices are 4. For the second letter, you have again 4 choices. 4 choices. So, for the second letter, you have 4 choices. So, you have 4 possible ways. So, 4 product 4 is 16. Am I right? So, as I told you already, if it is one position and 4 letters, okay, one position 4 letters means the total number of possible ways is only 4. If it is 4 position, 4 possible arrangement, 4 position and 4 letter means 4 factorial possible arrangements are there. Here there is only one position, okay, in this problem you have only one position, but you have 4 possible choices. So, you have total number of possible ways is only 4. Either you have to take A, B, C or D here. Here itself either you can take A, B, C, D or D. So, I just give you the detailed selection of 2 letters among these 4. Okay. If you list out the different possible arrangements first, let me start with A. Repetition is allowed. Okay. So, write down the different possible arrangements by taking 2 among 4. A, AB, AC, AD. Next, BA, BB, BC and BD. Next, CA, CB, CC, CD. Next one, DA, DB, DC, DD. So, totally we are having 16 arrangements. Am I right? With repetition is allowed means you have the diagonally you have AA, BB, CC, DD. Okay. So, repetition is allowed. If it is so, the total possible number of ways of selecting 2 of these letters among 4 is 16. So, either you can give your answer like this or like this. That is using the formula n is 4 part 2, r is 2 because you have to take only 2. So, letters at a time. So, 4 part 2 16. So, if I am going to explain this how this happen means, first position you have 4 choices, the second position you have 4 choices. Since the repetition is allowed, so you have 16 possibilities are there. So, I have listed out the 16 possibilities. What are the 16 possibilities are there for this problem if repetition is allowed? These are all the 16 possibilities. Okay. Now, I am going to explain one more thing clearly to you now. For the same problem, okay, if repetition is not allowed, what is your answer? Think of it. I just give you 30 seconds, okay, time. For the same problem, if repetition is not allowed, okay, you just strike out this. For the same problem, okay, if repetition is not allowed, what is the answer? If you understand the previous concept clearly, definitely you will give your answer within a second. Am I right? If repetition is not allowed means definitely we don't have these pairs A, B, B, C, C, D, T. The remaining is we have only 12 possibilities. Am I right? Or by make use of the formula, what is your answer? Since you are having 4, that is 4 out of 2. That is 4 objects. Among 4 objects, you have to choose only 2 at a time. That means 4p2 ways. 4p2 means simplifying 4p2, you get 12 possibilities. Am I right? These are all the 12 possibilities. Okay. If you understand without repetition means definitely you can give the answer with repetition immediately. Okay. Now I just give you this for your clear understanding, and you get a clear understanding about what is permutation without repetition and permutation with repetition. For the same problem, what happens if it is without repetition and with repetition. Okay. Now in case of words in without repetition, we move on to in case of words. If it is repeated and non-repeated letters, how can we calculate the different possible ways of arrangements? That is what we are going to discuss now. So I am going to take all in a single problem. Okay, bank, machine, how many different ways the word machine, Monday, banking, director and permutation be arranged if repetition is allowed. Okay, let me first take machine, M-A-C-H-I-N-E. So machine consists of 7 letters. So if repetition allowed, so if repetition allowed, so the word machine consists of 7 letters and also none of the letters repeats more than once. So the total number of ways of different possible ways of arrangements are n per r. Here n is 7 and r is also 7. So 7 per 7. Next let me take Monday. So we have finished machine and let me move on to next word Monday. M-O-N-D-A-Y. So here the word Monday consists of 6 letters. And look at here, none of the letter repeats more than once. So the 6 letters and repetition is allowed. If so, the number of possible arrangements are in 6 per 6 ways. Next we move on to next one, banking. B-A-N-K-I-N-G. Look at the word banking. Banking consists of 7 letters, 1, 2, 3, 4, 5, 6, 7. Of which n repeats 2 times. If n repeats 2 times means you have to take it in the denominator, since it is a 7 letter word. Am I right? So these can be arranged among themselves if repetition is allowed means 7 per 7. That is n is 7, r is also 7. So n per r formula here we have used. So 7 per 7 divided by 2 factorial ways. Next we take director. D-I-R-E-C-T-O-R. The word director consists of 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. So 8 per 8 and divided by r repeats here 2 times. So you have to take it in the denominator. So this gives you the total number of ways of arrangement. The last one, permutation. P-R-M-U-T-A-T-I-O-N. Permutation. So the word permutation has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 per 11 divided by, look at, is there any letters repeat more than once means here T repeats 2 times. So divided by 2 factorial. So you know, if that is you got a clear idea about if repetition of letter and non-repeated letters, then how can we calculate the different possible arrangements if repetition is allowed. Okay. Now for the same problem, if repetition not allowed. What is your answer? For the same problem, I am just strike out the word repetition is allowed. If it is a question, in how many ways, different ways the words machine, Monday, banking, director and permutation be arranged, which means repetition not allowed. Okay, nothing is mentioned about repetition, so which means repetition not allowed. If so, what is your answer? I am just give you 30 seconds, okay, of time to think about it. Okay, now most of you got an answer if you understand the previous concept very well, and now let me explain the answer for these questions in detail to you. Look at the word machine. So it has 7 letters, that is number of different permutations of 7 letters taking all at a time as given by the value 7 factorial. The next one is Monday, it has 6 letters, none of them is repeated, taking all at a time means 6 factorial is. Look at the word banking, it has 7 letters, the total number of possible arrangement is 7 factorial divided by 2 factorial since value and repeat 2 times. Look at the word director, it has 8 letters, so the total different number of, that is the total number of possible arrangements are 8 factorial divided by, here the letter R repeats 2 times, you have to take it in the denominator. And also same for permutation, the different possible arrangements are 11 factorial and T repeats 2 times, so you have to take it in the denominator. So now you got a clear idea about if it is repetition allowed, how can we calculate the different permutation, that is the different ways of arrangement of the given words, and repetition is not allowed, how can we calculate the different possibilities. Okay. Now, let me now move on to numbers. In numbers, as I told you already, there are 2 cases including 0 and non-zero numbers. Now, let me first take the problem that doesn't include any 0. Okay. How many 3-digit numbers? How many 3-digit numbers can be formed from 5, 6, 7, 8, 9? If repetition is allowed. If repetition is allowed, so here you have n is equal to 1, 2, 3, 4, 5 and r is equal to 3-digit number you can form. So r is equal to 3. By making use of the formula, you get 5 power 3. 5 power 3 is, that is n power r is the formula. Am I right? N power r is the formula if repetition is allowed. So 5 power 3 is 125 ways. But I am going to explain the concept underlying this to you clearly now. So you are going to form 3-digit numbers. Am I right? You are going to form a 3-digit number. So for the first digit you have 5 choices. Okay, for the first digit you have 5 choices, so you have 5 different possibilities. For the second digit also you have 5 choices, that is you have 5 different possibilities. For the third digit also you have 5 choices, that is 5 different possibilities, because the repetition is allowed here. So the total number of ways is 5 cube, that is 125. This is what the actual concept underlying this, but you can make use of the formula and give your answer like this. Okay. Now, how many 4-digit numbers can be formed from 2, 4, 6, 8 when repetition of digit is allowed? Here also problem involving non-zero numbers. So, you are going to form a 4-digit number. If you are going to form a 4-digit number means here n is equal to 4 and r is equal to 4. Okay. So, by making use of the formula n power r, that is 4 power 4, that is 4 power 4 is 2, 5, 6 ways. So I am going to, as usual, I am going to explain the concept underlying this. You are going to form 4-digit number. So for the first digit you have the 4 possibilities. Either you can take 4, 2, 4, 6, 8. 4 choices. So 4 different possibilities. For the second digit you have 4 choices, 4 different possibilities. For the third digit also you have 4 choices, so 4 different possibilities, and fourth digit also you have 4 choices. So these product gives you 4 power 4, that is 256. This is what the basic concept underlying this, and that is under the formula n power r. Okay, don't simply mug up the formula. This is what the actual concept underlying behind the formula n power r. Okay, now next, for a set of 6 true or false questions, find the number of ways of answering all questions. So there are 2 possible answers which are true or false. Am I right? So here n is equal to 2. Am I right? There are 2 possible there are 2 possible answers. So that is true or false. So here n is equal to 2, and for the number of for a set of 6 true or false question means you get 2 power 6, that is 64 ways. I am going to now explain how this gives you 64 ways. So the number of ways of answering so totally first write down the questions 1, 2, 3, 4, 5, 6. So totally you have having set of 6 questions. The number of ways of answering the first question is 2. There are 2 possibilities. Second, either you can give true or false. For the second question also you have 2, third, fourth, fifth and sixth. Like that you have only 2 choices. So the 2 power 6, that is 64 ways. Next we move on to how many 3 including 0. Okay, so far we have discussed non-zero numbers. If repetition is allowed, then how can we calculate the different possible arrangement? Now let's move on to including 0. That is how many 3-digit number can be formed from 0, 6, 5, 3, 4. If repetition is allowed, listen carefully. Okay, as I told you already, if you take 0 at the beginning, definitely the 3-digit number become 2-digit number. So you omit 0 as a first choice. Okay, you omit the first position value as 0, and you have to take any of the remaining value as the first position, that is the remaining digit as your first position. So here you have 0, 6, 3, 5, 4, that is 1, 2, 3, 4, 5. So you have 5 digits. Out of 5 you have to form 3-digit numbers. So we are going to form 3-digit number. Am I right? So for the first position you have only 4 choices. Either you can take 6, 5, 3, 4. You didn't take 0 at the beginning. If you take 0 at the beginning, definitely the 3-digit becomes 2-digit number. But the question is you have to form a 3-digit number. So for the first position, okay, or the first digit, for the first digit you have only 4 choices. They are either 6, 5, 3, 4 you can take. So you have 4 choices. For the second digit you have 5 choices. That is 5 choices means either you can take 0, 6, 5, 3, 4. You have 5 choices. Likewise for the third position 2, that is for the third digit you have 5 choices. Either you can take 0, 6, 5, 3, 4. That is you have 5 choices. So first position you have 4 choices, second digit you have 5 choices, and for the third digit you have 5 choices. You know why? Because if you take 0 at the beginning means definitely the 3-digit number become 2-digit number. So the total number of possible arrangements 4 product 5 square. 4 product 5 square is 100 possible ways of arrangement are possible for this problem. Next, how many 4-digit numbers can be formed from 0, 1, 2, 3 if repetition is allowed? The same process as we carried out in the previous. Okay. So we are going to form a 4-digit number. Okay. For the first digit you have 3 choices. Okay. What are the 3 choices? Either you can take 1, 2 or 3. For the second digit you have 4 choices. You can now take any of the digits including 0. Third position to third digit also, fourth digit also you have 4 choices. Okay, so your total number of possible arrangements is 3 product 4 cube, that is equal to 192 possible ways of arrangements are there. Okay, now up to this we have completed permutation with repetition and without repetition. Next we move on to circular permutation. So far we have discussed linear permutation, not a circular permutation. Linear, that is linear permutation means the objects are arranged in a straight line like this. If it is a circular permutation means the objects are arranged in a circle. That is, an arrangement of object in a circle is nothing but a circular permutation. Okay. So far we have discussed about linear permutation without repetition and with repetition. So in a linear permutation, you know already the objects are arranged in a line. For example, let me take letters L, M and O, P. If you take these letters, that is to arrange the 5 letters L, M and O, P without repetition, you know the formula to calculate the number of arrangements, that is we make use of the formula NPR. NPR is nothing but N is 5, P5, that is number of arrangements of taking all at a time, that is different possible arrangements are 5 P5, that is 5 factorial, that is there are 120 possible arrangements are there. So if it is in terms of without repetition, if the 5 letters are given means we make use of the formula, and there are 120 ways of possible arrangement. You can give you 120 different possible arrangements among these letters. Okay. Now I am going to explain this in a different way for your clear understanding. So for the first question, okay, 1, 2, 3, 4, 1, 2, 3, 4, 5. So I am going to take 5 letters. I am going to arrange the 5 letters in 5 positions. As for the first position, you have 5 different possibilities. Either you can take L, M, N, O or P. For the second position, you have only 4 different possibilities. For third position, you have only 3 different possibilities. For the fourth position, you have 2 different possibilities, and the last position, fifth position, you have only 1 different possibilities. So the product of all these is nothing but these represent the position, second, third, fourth and fifth position. So the product of all these gives you 120. That is 120 5p5, that is n factorial. N factorial is nothing but 5 factorial. Here we take only 5 objects, so 5 factorial, that is 120. Okay. So totally we have 5 factorial ways, that is 120 ways. In general we have to say if it is n objects means we totally have n factorial possible arrangements, that is there are n factorial possible arrangements we can give. Okay. So this is in case of linear permutation. Now let me now take you the concept of circular permutation by taking the same example. Okay. So in a circular permutation, the objects are arranged in a circle, not in, that is in a closed curve, that is like that's nothing but a circle. So in a circular permutation, remember that there is no starting point and ending point. Okay. Now, so in a circular permutation, first we have to fix a starting point, right? If so, if we are going to fix the first point, then we have to arrange the 5 letters, that is K, 2, 3, 4, 5. Here we are taking 5 letters, right? That is K, L, M, N, O. Okay. Here I am going to fix the first position. I am going to fix first position as K. Okay. If I am going to fix the first position, for the first position I have only one choice. That is, I have to take only K alone. Okay. The first position we have only one possibility or one choice. For the second position we have 4 possibilities. Either I have to take M, N, O, K. Okay. Whereas in the third position we have 3 possibilities. Whereas in the fourth position we have 2 possibilities, and also for the fifth position we have 1 possibilities. So the total number of arrangements is here 1 product 4 3 2 1, that is 1 product 4 factorial, that is 4 factorial. So, if we take 5 letters at a time, the total number of possible arrangement is 4 factorial, that is 1 less than the factorial value. Am I right? If it is n, suppose if you are going to take n objects at a time, means the total number of circular, that is possible circular permutations are 1 less, that is n minus 1 factorial ways arrangements we can give. So, if it is in terms of linear permutation, means we can give n factorial possible arrangements. If it is in case of circular permutation, means we can give n minus 1 factorial possible arrangements. I will explain, that is I will explain what is the difference, because let me have a special case, that is if we have LMNOP, we have 120 ways. In case of linear permutation, that is in terms of circular permutation, we have only, that is 24 possible arrangements are there. So, let me think why there is a huge difference, okay, between the linear permutation and circular permutation. Okay, let me think about why this deviation, large deviation from for a linear and circular permutation for the same problem. Okay, for the same problem. So, now here let me now take the letters K along the circle. Let me now take these letters, that is K, L, M and O along the circle. I am just going to fix a starting point. I am going to fix the starting point here as K. Just a minute. Okay. If I am going to place the first point, starting point as K, then the different possible, that is the different, that is if you place these letters in a linear permutation, then we have 5 different permutations. Okay, if I am going to just write down these 5 letters in a circle like this. If I am going to give a linear permutation for this, I have K, L, M and O. Next, take L first. L, M, N, O, K. Next M, M, N, O, K, L. Next start with N, N, O, K, L, M. Next start with O means O, K, L, M, N. If you start with K, you have one linear permutation. Start with L means you have a linear permutation, L, M, N, O, K. If you start with M means you have M, N, O, K, L. Like that. Okay, but in a linear permutation these are different, that is you have 5 different linear permutation. So, you have 5 different linear permutation, but for this we have only one circular permutation, that is K, L, M and O. K, L, M and O. You have only one circular permutation. So, in a linear permutation these are all different, these 5 all are different. In a linear permutation, these 5 are different, but as in a circular permutation, these 5 are same. That is, these 5 represent only one permutation, that is K, L, M, N. As I told you already, in a circular permutation, there is no starting and ending point in a circular permutation. Here we consider only the relative positions. Okay, so in a linear permutation, if you are having 5 different linear permutation, that is equal to 1 circular permutation. So, the 5 linear permutation is equal to 1 circular permutation. So, 5 linear permutation is equal to 1 circular permutation means, so 24 product 5 is 120. Is it correct? 24 product 5, that is 24 circular permutation. Circular permutation is equal to 120 linear permutations. Am I right? 24 circular permutation is equal to, if you multiply this by 5, you get 120. Am I right? So, the 5 linear permutation, different permutation is equal to 1 circular permutation, because of the reason that in a circular permutation there is no starting and ending point. We have to fix the starting point and proceed further. Okay. Now, you got the clear point, about why there is a deviation like this from a circular permutation to linear permutation by taking the same example. Okay. Now let me move on to the concept once again. Circular permutation means an arrangement of objects as a circle. So under this we are having two categories. In a circular permutation, if the clockwise means counterclockwise, this direction, okay, this direction represents clockwise and this direction represents anti-clockwise, okay. This is clockwise direction and this is anti-clockwise direction. So this clockwise direction, the circular permutation image, so this is clockwise and this is anti-clockwise. So this is clockwise and this is your anti-clockwise. So the circular permutation in which clockwise and anti-clockwise arrangements gives you the different permutations and same permutation. These are all the two different things we have to concentrate while dealing with circular permutation. The circular permutation in which clockwise and anti-clockwise arrangements gives you different permutation means you can make use of the formula n minus 1 factorial to give the number of arrangements. Suppose if it gives the same permutation means you make use of the formula n minus 1 factorial divided by 2 to give the different possible arrangements, okay. How it is, how do you identify? It is of same, it will give you the same permutation, it give you the different permutation. I will explain this by giving you a very simple example. So the circular permutation in which clockwise and anti-clockwise arrangements gives a different permutations, under which I am going to take one simple example. Seating, let me take an example as seating arrangement of persons round a table. I am going to take the seating arrangements of persons in a round table. So the number of ways in which n persons, let me take, there are n persons means the number of ways in which n persons can be seated around a table is in n minus 1 factorial ways, okay. Suppose if you take this as a starting point, okay, the number of ways of different possible ways of arranging the person sitting around a table is in n minus 1 factorial ways. Suppose if you look at the clockwise direction and the anti-clockwise direction, so at this point, okay, I am going to fix this point. If you look at this in the clockwise and the anti-clockwise directions, you will get a different permutation. Different permutation means you will have a different persons in different positions. So that will give you the different arrangements that leads to different permutations. So the number of arrangements is given by make use of the formula n minus 1 factorial. Let me move on to this again. The circular permutation in which the clockwise and anti-clockwise arrangements gives you the same permutation. Gives you the same permutations means I am going to take a well-known example, arranging some beads to form a necklace. For example, I am going to take arranging some beads to form a necklace. So here I am going to fix the first question, okay. I am going to fix the first bead here. So the number of ways in which n different beads can be arranged to form a necklace is n minus 1 factorial divided by 2. Now you ask why? Why this value? That is, here itself we have n minus 1 factorial, here itself 1 minus 1 factorial, but here we have to divide this by 2. You may ask me the question why? Because in case of necklace with different beads, the different arrangements when we looked at from the opposite sides become anti-clockwise, okay. That is, in order to remove the similar arrangements, we have to divide the total arrangement by 2. Here, if you look at the clockwise and anti-clockwise direction, mean it gives you the same arrangements. So up to this, till to this point, if you look at this clockwise and anti-clockwise are both at the clockwise and anti-clockwise throughout the whole. If you look at this means this gives you the same arrangements. So in order to arrange that is, in order to avoid the similar arrangements, you are going to divide the total number of arrangements by 2, okay. That is, if you look at both clockwise and anti-clockwise direction, it will gives you the same permutation means you make use of the formula n minus 1 factorial divided by 2. So if it gives you the different permutation means you make use of the formula n minus 1 factorial to give the number of arrangements. So now let me take 3 problems under this case. In how many ways 7 persons be seated at a round table? 7 persons be seated at a round table means here say 7 persons can be arranged in a table in 7 minus 1 factorial ways, that is in 6 factorial ways. Am I right? Because if you look at from the clockwise direction and the anti-clockwise direction, by fixing the first person, so you get a different arrangements. Okay, 1 2 3 4 5 6 7. If you look at the clockwise and the anti-clockwise direction, you get the different persons from different positions are there, so you get a different arrangement. So you make use of the formula n minus 1 factorial, that is n is here 7, so 7 minus 1 factorial is 6 factorial ways of possible arrangements we have to give for this problem. Now, in how many ways can these letters A, B, C, D, E and F be arranged in a circle? If you are going to arrange these in a circle, A, B, C, G, E and F. So, first you have to fix the first letter. So, the number of ways to arrange these letters in a circle is 6 minus 1 factorial. So, since we are having 1, 2, 3, 4, 5, 6. So, you know the formula n minus 1 factorial, n is 6, 6 minus 1 factorial is 5 factorial, that is 120 different possible ways of arrangement. If you look at both clockwise, suppose if you are going to fix the first position A, if you look at the clockwise and the anti-clockwise direction, you will get a different permutations. Okay, so that's why we make use of the formula n minus 1 factorial and gives you the number of possible arrangements for this problem. Okay, now let me move on to the last problem. Find the number of ways in which 7 different beads can be arranged to form a necklace. So, fixing the position of one bead, the remaining beads can be arranged in 6 factorial ways. Okay, fixing the first position of beads, the remaining 6 beads can be arranged in 6 factorial ways, and the required number of possible arrangements is given by divide this value by 2, because if already I told you, in case of a necklace, if you look at both clockwise and the anti-clockwise direction, it gives you the same arrangement. In order to remove the similar arrangements, we have to divide this by 2. That's why we make use of the formula n minus 1 factorial divided by 2. Here n is 7, 7 minus 1 is 6 factorial divided by 2. 6 factorial divided by 2 is nothing but simplifying this, you get totally 360 ways of possible arrangements we can give. So, up to this we have completed all about permutation, both with repetition, non-repetition and also in circular permutation. Okay. So, at last, before completing the session, I will just try to say one thing. So, while you are going to prepare for any competitive examination, first you have to concentrate on what you are going to prepare, and then concentrate, then you have to understand and then practice. So, understanding, try to concentrate first, then understand and practice as lot as you can. Okay, while practicing, you need some shortcuts and tricks or some tips to find the solution, because both maths and aptitude both are different, because maths is concept oriented whereas aptitude is skill oriented. So, in aptitude you don't need the procedure, that is you don't need any steps, because by giving the question how fast you can get the solution using some shortcuts is very important thing. This saves you much time in your examination. Okay, so by keep this mind, okay, practice well, and guys, thanks for watching my video. Thank you. See you all again in my next video.